So we want to know something about the population mean, mu, for the earnings of college graduates, but we don't have the population mean or variance. So we conduct a survey and get the following information. We get our sample size of 20, our sample mean, and our sample standard deviation. So from this, we can look at if X bar is distributed normally with a mean mu and the variance is sigma squared over n, then this means we can standardize this such that X bar minus mu over the square root of sigma squared over n is also distributed normally with a 0, 1. But the problem with this is we actually don't know sigma squared. So we can't use this equation, but what we can use is a similar equation, which is the t-distribution. Instead of sigma squared, we're going to use s squared. And so this is where we get x bar minus mu over the square root of s squared over n. This will be distributed not as a normal, but as a t n minus 1 distribution. So this is the equation that we're going to use to be able to answer this equation, or this question. So let's go ahead and apply that. So we can set up the probability that we're between certain values. So here's our t alpha over 2 of n minus 1 is less than x bar minus mu over the square root of sigma s squared over n is less than the same t alpha over 2 n minus 1. And we want that equal to 0.95. So let's go ahead and look up what that critical value is. So because alpha in this case is 0.05, which is 1 minus 0.95, we want to look up alpha over 2 is equal to 0.025. So this is what we want to be able to look up and find the t-distribution with 19 degrees of freedom. So let's go ahead and go to our table. So we're looking at 19 degrees of freedom, going right there. And then we're going to look at t is 0.025. And so that's where we get our 2.093. And so coming back here, we're going to look at the probability that negative 2.093 is less than x bar minus mu over square root of s squared over n less than positive 2.093 is equal to 0.95. Well, in this case, we have x bar. Oops, let's do this in red. We have x bar, we have s squared, we have n, so we can find the confidence interval of mu. Now, the other thing I can do is I can just rewrite this real quick to say that the 95% confidence interval is equal to x bar plus or minus my t alpha over 2 n minus 1 times the square root of s squared over n. So this is the equation for the confidence interval, and that's just rewriting this equation right here. And so now I can plug and chug. The confidence interval of a 95% confidence interval is equal to x bar, and I have that. That's 61,000 plus or minus my t, which is 2.093, and that's both the positive and the negative t, times s squared over n, which is the square root of 13,000 divided by n. And so I have all these numbers. Oh, n we have. So n is 20. And I would just plug and chug, and this is where I get the confidence interval of a 95% is equal to, so I could do the minus first and then the plus. And so this would equal 54,916 and 67,084, which means that I am 95% certain that the true population mean of earnings is between $54,916 and $67,084. And that is centered around the sample mean, which I got was 61,000. So here is how we can solve for a confidence interval when we don't have the population variance, but instead use the sample variance.